So you notice that in a power circuit, of course, you need the power source, which in this particular case is a three-phase system, because we're dealing with three-phase motors and whatnot. Okay, so in the Explorer, on the left section here, we're going to use the standard electrotechnical NEMA. Okay, this is what I'm going to be working with. So twaisa pali electrotechnical NEMA napakubala tuwala palela ndati power, and then of course we're looking for energy source. Okay, looking for an energy source, which in this case happens to be a three-phase system, and also tuwala bule equate neutral. Okay, so this is our power source. Now you may ask to say, what's going to be the voltage rating for these motors that we have in our schematic, which is going to say the crusher, the vibrator motors, and the lubrication pump motor, and the hydroset motor. So these basically are going to be rated for 550 volts. Okay, we can work with the 208 volts, but okay, let's see. If we come under motors, let's pick on an asynchronous motor. So three-phase asynchronous, let's pick on this one. Okay, and then let's check the voltage rating, characteristic data. So this motor is rated for a line voltage of 480 volts. Okay, with a power factor of 0.87, but the interest is in the voltage rating iwalela ndati 480 volts. So we want to see this display alias, display value, and then we also want to see the rated full load current, which is this one, display value, display alias, and then we're going to just close this. Do we need to see the torque? We don't need to see the torque. We don't need to see the angular speed. Okay, the torque. Okay, no, maybe not. I don't need to see the angular speed. This is the identifier, but I just need to see the rated voltage and the rated current, like this. So these are related to our synchronous motor. Okay, so we have these. Now the reason why we're looking at this, because to achila for kumonati rated voltage line to line in 480, so we're going to left double click on this, and then we're going to change the voltage to 480. Okay, change frequency, because this won't be needed for our simulation. Okay, because if we to 150 Hz, but in this particular case the default is 60. We can also change it to 50. Okay, you can change this to 50 if you want, but we'll leave it at 60 Hertz. Okay, so our voltage is now 480 volts with a neutral. Okay, so this is going to be our power source. Okay, and then the only thing I want to do is I'm going to create a terminal block. Okay, so I'm going to come under electrotechnical to where it says AMA lines and connections, and I'm going to look for junctions, and then I'm going to pull up this one here. Okay, so I'm just going to come into home, polyphase wire. Okay, so I'm going to do this. I'm going to do this, and then of course red, yellow, blue. Okay, so when this is done, I need to identify that I've got 4 loads. Okay, 4 loads to be driven. And what I mean by 4 loads to be driven, if you look at our control circuit, to quite now to quite a crusher lubrication control, this is clearly driven by a 3-phase motor. So this is motor 1, the main drive. Okay, this is the main motor for the crusher. It's also a 3-phase system, a 3-phase motor, so that's 2 motors. And then the crusher hydroset control is also targeted at the control of a single motor, so that's 3 motors. And then for the crusher vibrator control, you've got AMA vibrators abiri, the ones which are designated as vibrator 1 and vibrator 2, right? Now each vibrator has got a set of 2 motors. Okay, so clearly we can just go for 4, right? The lubrication control, the main drive control, the hydroset control, and the vibrator control. So all vibrator 1 control, vibrator 2 control. So that's like 5 motors to be controlled. So 5 motors to be controlled, that would imply 3 by 5, 15 terminal blocks. Okay, so I'm going to modify this here. Okay, I'm going to modify this to have 15 terminal blocks. So I'm going to come here and say 15. When that is done, I'll have this. Okay, and then having gotten this, I'm just going to form jumpers across for each 3-phase. So this is motor 1, motor 2, motor 3, motor 4, and motor 5. So I'm just going to come to where it says jumper. Okay, jumper here. So I'm going to do this. Then I'm going to do that. Then I'm going to do this. Okay, then I'm going to just pull this up a bit like so. So this is power. Okay, let's see. I'm going to pull it up like that. I'm going to do it like this so that we see where I'm coming from. Okay, so it's going to be like this. Okay, and then having done this, I'm going to do the same thing with the next set. Okay, because clearly we're going for red. Okay, maybe I need to pull this up, and then I can pull this down like so that it's clearly red, yellow, blue. So can I change this power? Jumper. I'm not being given the liberty of choosing this as a particular color. Okay, because anyway, so I'm going to create another set of jumpers. Okay, so I'm going to go like between this one here, okay, and then between this one and the next one, then between this point and this other point. Okay, and I'm going to do the same thing for the next set of terminations. Okay, I'm going to do like so. Then I'm going to do like this, like so. I'm going to do like so. Okay, so when this is done, the only thing I need to do is I need to make links. Okay, then I need to come here and then do links. So what I just need are output links. Okay, single pore input link, single pore output link. This is what we need. I'm going to come here. I'm not going to do anything just yet, okay, because I need to create more like copies for each one of these points. Okay, I'll do it like so. I'm going to do it like so. Okay, so we're going to do it like so, and then this is going to be, okay, just for clarity, I'm going to call this as R1. Okay, I'm going to call this as R1. Okay, this becomes our R1. Okay, let's see, data item identifier. This is going to be R1 still. Okay, and then we're going to move on to the next position, and then this is going to be Y1. Okay, association, this is going to be y1. Then data, internal item identifier is going to be y1, item identifier y1. And then this other position is going to be b1. Okay. Then again, item identifier, I'm going to change this to b1. Then when this is done, I'm going to move to the next set of power terminals. Okay, I'm just going to refer, because this is a terminal block, and then these are just terminations on this terminal block. Okay, so the next set is going to be R2, Y2, B2. Okay, so this is going to be R2. Okay, item identifier is going to be R2. The next position is going to be association. It's going to be Y2. And then item identifier is going to be Y2. And then of course, next position, association, is going to be RYB2. Item identifier B2. Okay, right? So essentially, the only thing I'm just doing here is I'm just getting this to be what? To be more like our terminal block, where we can tap all the power points that we need. Okay, so this terminal block is essentially 480 line to line. Okay, because this is like our voltage 480. So between any 2 points, between point 1 and 2, that's 480, 2 and 3, 480, that kind of thing. And then of course we've got this. I may need just one other terminal. Okay, I need one other terminal, so I'm going to call this 16. I'm going to create a jumper. For this one, it really doesn't matter which point we pick. Okay, because I just need this for the control. Okay, and then what do we do? Okay, let's copy this. Then this one we're going to call okay, so let me just call this control. Okay, because I need this for control supply. Okay, for the control transformer. Oh, come on, how do I not do this? Data, item identifier, item identifier. Okay, let's check. Control, and then item identifier is control. Okay, which is the last point. Okay, so now that we have this, I may also need another terminal block, just one this time. Okay, so I'm going to go for terminals, junction. I will need just one. Can I just get one? And on this one, I'll just do the neutral. Okay, we do that. Okay, okay, so this is basically our neutral block, our live block. Okay, so when this is done now, I also need to copy this to that position. Okay, and then this I'll call anyway association. I'm just going to call this as neutral. Okay, I'm going to call this as neutral for control. Okay, neutral for the control, data item identifier, it's neutral for the control, neutral for control, R1. Did I do this? Okay. Neutral for the control, that's done. So this is basically the neutral for the control. Okay. So when we do this, ladies and gentlemen, now we can move on to say the general configuration. Yala wakwati where we've got the three-phase supply, and then we've got the circuit breaker. Okay, now this particular circuit breaker has got both overcurrent and residue current protection, and then maybe we just need a little bit of creativity and pushing some thermal overload. Okay, so thermal overload, residue current protection, and I believe instantaneous overcurrent. Okay, so residue, thermal overload. So basically this particular circuit breaker, we expect it to have like thermal overload and earth leakage protection. So having said that, the thing we can do is we can come to where in the Explorer, okay, in the Explorer we can come to where it says control. Okay, so we can come down, control, and then under protection we will look for particular circuit breaker. Okay, so this is what thermomagnetic residue current circuit breaker. We could have put in one like this. Okay, so this would work in this position. Okay, it would work in that position, but again, if we did this, we wouldn't have a differentiation in the term by way of Yadama control points. We are not going to have a distinct contact to label as 4DE3 or 4DE2 because they are going to be bundled into just the same association. Okay, we're going to have to double click on this one and then go to where it says builder, and then we're going to add a new group, add new contact group. Okay, I'm going to go for a normally open contact like so, and then okay, this is pretty much it. So if I created another contact group which is normally open and then I said okay, you'd notice that both of these would have the same associated label as CB1. Okay, so like this we wouldn't have the option of creating a distinct 4DE3 and a distinct 4DE2, so we don't want this. Okay, quite all right. E-breaker is capable of thermal overload and residue current protection, which are part of this. Okay, and then of course this section would imply that it's also capable of tripping under inrush current conditions. Okay, like if the current rises beyond a certain limit, this will trip. Okay, so let's look at this builder. Okay, this one here. So it's magnetic tripping device. Okay, this is like a magnetic tripping device, which is what that is. Okay, so we're not going to pick this, but rather we're going to pick discrete components. Okay, so we're going to come to protection, then we're going to look for a circuit breaker. Okay, so we're going to look for a circuit breaker, a NEMA one at that. We're going to pick a circuit breaker, and then we're going to pick on thermal overload. Okay, yeah, which is here, and then residue current. Okay, so this is residue current relay, 2 poles. Okay, but clearly we're talking about a 3-phase system. Okay, we're talking about a 3-phase system. So we're going to left double click and then go into the builder, we're going to left double click on this, and then we're going to say we need a 3-pole breaker. Okay, and then let's see, what are you rated for? So the breaker is rated for maximum AC design voltage of 400 volts. We may want to increase this to maybe 550. Okay, we'll raise that to 550. The rated design current is 32 amps, which is fine because our motor is like 14 amps plus. Okay, so this is okay. So say okay, and then when this is done, we would want to move on to the thermal overload. Okay, again, hapana pena hapa, we need this to be 3-phase. So left double click, then choose 3 poles. And then what are you rated for? The rated voltage is 400, so we set 550. Okay, the thermal current setting is 30 amps. Thermal current activation, thermal current setting. Rated design current is 32 amps. Okay, then thermal current setting. Our motor is what? Cancel. So let me just take you back to this. Okay, let me take you back to this. Our rated current is 14.9 amps. Okay, it's 14.9 amps. So when we talk about thermal overload, and then we're being told that the thermal current setting is 50, is rather 30 amps. Okay, so what do we want to do? Get to do rated design current. I'm going to change the thermal current setting to lower than the full load. Okay, for now I just set it at 12 amps. Okay, kind of current is AC. Automatic reset, nope. Let's go down. Maximum thermal current setting. So for a motor rated at 14.9 amps, then the maximum thermal current setting we can go for is maybe okay, maybe 20 amps. Okay, 20 amps, the minimum AC design voltage. We're not going to touch this. What's the maximum AC design voltage? Maximum AC design voltage is 550. I think we've changed all the things that are of particular interest for this one. Okay, and then so we have the 3-phase overload device. Okay, the same thing for the residue current device. Left double click on the schematic, then we're going to say is 3 poles. Okay, and then we're going to look at the main contacts. We're not going to change anything here, so just say okay. Then yapanga maisalulesha is talking about the rated design current, which is like 32 amps. This we're not going to change. Then the residue current device sensitivity is 0.03 amps. So we want to see this, and then display alias, because we will need this later, right? So and then the other thing is the maximum AC design voltage. We need this to be 550. Then the frequency we'll leave at 60. The minimum AC design voltage we're not going to touch. The frequency minimum rated, we're not going to touch this. So I think this is just about it in here. And then okay, this is here. I believe this is for this one here. Then this is the thermal overload. Okay, so this is how they stack up. So we're going to have them like this. Okay, and then the other device you'd find is the magnetic relay. Okay, so this is like the magnetic relay here. It's just an addition. It's not part of this, but I'm just adding it for the crusher motor. Okay, for this 300 kilowatt motor. Okay, So let's see. We're going to do this. Left double click, choose three pores. Okay. Then we look at this. So the rated design current is 32 amps. Okay, it's 32 amps. And then rated AC design voltage is 480. Frequency 60 Hz, we're not changing. Maximum setting current factor of the magnetic, okay, it doesn't, of the magnetic what? Of the magnetic curve. Maximum setting current factor of the magnetic curve. Okay, it's supposed to be 19.5, and it's saying that we're talking about the actual current over the nominal current. Okay, so this is what this is, and then everything else we're not going to touch. Okay, because apart from the maximum AC design voltage, we need for this to be 550. Rated design current is 32 amps. Okay. Now if you see, I'm not really considering the 300 kilowatt motor. Okay, I'm just doing this with view of the 14.9 full load drive. Okay, which is in this case I think it's about 5 kilowatt. Okay, this one rated power is 5 kilowatt. So this I'm not going to change, because if we change this, then we need to recalculate a whole lot of things, and this is just to show you the concept. Okay, so now we have these components. Okay, we have all of these. So this we don't need. And how do we stack these up? So we're going to have the circuit breaker, the overload, okay, residue current should be last, then this one here, then this one. Okay, like so. We're going to stack them up like this for the crusher motor. Okay, then the only other thing that we need is this is a circuit breaker, right? Now we need the contactor for control. So we're going to come to where it says contactor coils, and then we're going to pick an AC contactor coil. Okay, so we're going to pick this one, and then the designation for this will be 2AC1. Okay, this is going to be our 2AC1. So I'm going to left double click, and then I'm going to go to where it says item identifier, and then this is going to be 2AC1. This is going to be 2AC1, like so. Do we have the builder? Okay, so builder, and then I'm going to add a contact group. Okay, and then the contact is going to be normally open contact. Okay, I'm going to have 3 of these. I'm going to just gang them up because it's a 3-phase system, so I need 3 contact points. So I'm going to say okay, and then we'll come back if we need another auxiliary of this. Okay, so for now it's done. Let's put it to the side like so. Put the symbolic name down there. Free up the connection port names so that maybe we can pull them apart like this, so that we get to see everything that is happening, like so. Like so. Okay, so now this is going to be our contactor. Okay, let's see, what do we have here? Relay control voltage. What's this I'm seeing now? maximum voltage factor, rated control circuit voltage. But why? Oh, maybe I'm looking at the wrong thing altogether. So let's see. Okay, so here what do we have? Contact rated operational power is 3600, but the motor, like we saw, okay, let me just do this. Okay, this motor here, it's 5 kilowatts. Okay, it's rated for 5 kilowatts, so the rated power for this is 5 kilowatts. Okay, which is why when we talk about these contacts, okay, we talk about these contacts builder, when we do this power, okay, rated contact rated operational power 7500. Okay, rated operational voltage, the voltage is fine, I'm not going to change it. The contact rated operational rated conditional short circuit, you may want to have this in kiloamps. Okay, so let's see, 10 1 kiloamp maybe. Okay, because our motor is like 14.9 amps, 10 times about 150 amps. So this should work. Okay, so the contact, I'm just putting values which are random but within safer limits. Okay, and then of course contact rated uninterrupted current. And then rated insulation voltage 690, rated impulse withstand. Okay, contact rated operational current. Contact rated uninterrupted current. This one, let's going to go for 20. So you notice that the contact rated operational current will determine the rated making capacity. Okay, so if I say this is like 150, I can't set the rated making capacity, but I can set the rated operational current. If I say this is like 15, then this one comes to 150. Okay, so our motor is 15 amps times 10, that's 150 amps. So if I go for 20, okay, if I go for 20, then this should be 200. Okay, that should be 200. So contact rated making capacity is like 200, and then rated operational current is 20, rated impulse withstand voltage 6000, and then rated insulation voltage 690, and then utilization category AC 15, rated operational power 75, and then what else? That's just about it. Rated contact conventional enclosed thermocurrent. Okay, so if you notice, I'm not referencing any technical data. You can pick up any data sheet and then you can pick these values from there. Okay, But this is based off of the fact that we're dealing with a 5 kilowatt motor. I haven't changed the default. It's 5 kilowatt. So if it's 5 kilowatt, my interest would be in the rated operational power. So I've picked this as 7,500 against a 5,000 drive. Okay. And then the other thing is the contact rated operational current. I've stated it as 20 amps because I know the full load is like 14.9. So 20 is reasonable, okay? Even though you can even pick 40 amps if you want, or 30 amps, but I'll work with this one. And then we can't set the contact rated making capacity because it's automatically calculated based on what you put in this section, okay? So having said that, I think we can leave everything else as default, okay? So we're sorted with this one. We just say save and then close this. So now we have a full set of components. Okay, we have a full set of components. Let's see. Let's put this one down here, and then OL1 is as good as 40E3. Okay, so this is 40E3. This is 4. This is 40E3. And then this is 40E2. That's 40E2. And then we have our drive, okay, which we're going to call as crusher main drive, okay. So SC1 is the crusher main drive. SC1, that's crusher main drive, okay. So that's the crusher main drive. So which is this one here, okay. Maybe let's push it a little bit to the left. So the crusher main drive is like so, okay. And then of course the only thing we need to worry about is the earthing point. So here we need the ground, okay. Just connect this to the ground, declare this as power ground, okay. So that's done. And then we may just need to do a little bit of housekeeping, okay. We need to do a little bit of housekeeping. So we can pick this one. And then distribute horizontally, okay, so that we get a little bit of even distribution. So okay, we still have the port names free, so let's pull this out a bit like so. Okay, we do it like so. So the only thing we need to do now is link these components together, okay. So this we did not have in this schematic, okay. We did not have in the power circuit, so I don't really know what to assign it to, okay. But to just not complicate things, we can just do away with this part, okay. We could use it, but to stay true to the original schematic, we'll just leave it out, okay. So the only thing that we're going to do now is we're going to link them up. So polyphase wire, we're going to do that. Okay, so when we do the linking like this, so the only thing is so this basically completes the power contactor, thermal overload, residue current. Okay, so it will be pretty much like this. Maybe let's put this one on top so that we have a little bit of clarity. Okay, so when this is done, the only thing we need to do is we need a power source on this end. Okay, so that's where now we need input links on the input side related to the output links. So we go to where it says link in the Explorer, then go for input links. Okay, output link, input link, like this here. The first one I'll link to R1. Okay, and then I'm going to go into data. The identifier will be R1. Okay, as linked. Then I need to transform, rotate left. Then I just need to do this. Okay, like that. Then I know I'm going to need to link these other two positions. Okay, and then this will be Y1. Okay, association will be Y1. Item identifier will be Y1. And then this is going to be B1. Okay, association will be B1. Item identifier will be B1. So it's going to be like this, so that when we do say simulate, we're going to have something like this. Okay, so this is exactly what we're trying to say. Okay, but here, okay, let's see, simulate, the live lines are red and the de-energized points are like in black. Okay, so that's what this is. Okay, so now you notice that this is actually just the power circuit. Okay, and then the power circuit for the lubrication pump will be exactly more or less like this one. Okay, so we can just copy this whole thing. Okay, we can copy this. Now again, the only thing we're going to do is do the linking. Okay, so this is going to be R2, Y2, B2. Okay, so this is going to be linked to R2. So this is R2. This is R2. R2, Y2. Okay, so it's going to be Y2. and then this is going to be B2. Okay, association link to B2, item identifier B2. Okay, like so. And then we just need to close this, and then we've done all the linking. Okay, CB1, MCR2, OL3, OL4, and then this now becomes the lube pump. Okay, the lubrication pump. Okay, so this data we're going to name as lubrication. Okay, this is going to be the lubrication pump as a controlled drive. Okay, so this is the lubrication pump. I'm not going to change the line voltage or the rated motor current. Okay, I'm just going to leave this one as default. Okay, but the only key thing is now we need to relate to the control. And what I mean by that is when we talk about the lubrication control, okay, you notice that the overload, the thermal overload is 4DE3. Okay. Oh, what is this now? Crusher lubrication. Okay, crusher lubrication 4DE3. For trip. So the lubrication is 4DE3, 4DE3, 4DE2 was the main drive. So the lube pump is 4DE2, 4DE3. So if you look at the main drive, it's 2AE2 and then H5A. So the overcurrent for the main drive is 4D is what? It's the overcurrent for the main drive, okay, is H5A, and the earth leakage is 2AE1. Okay, I think I pretty much mixed these up, which we can control. Okay, because the lubrication is the lubrication control is the one which has got an earth leakage of 4DE2 and then a thermal overload of 4DE3. So these two elements are for the lubrication pump. Okay, so that we can easily adjust. Okay, we can just think of ourselves as the adjustment bureau. Okay, so I'm going to just get this. I'm going to move them down here. These unassigned ones. And then I'm going to kind of put these up. Okay, I'm going to put these up. Control Z. I'm going to put this up like so. And then I'll just make corrections for the main drive. Okay, so for the main drive, we're saying the residue current for the main drive is earth leakage is 2AE1. So this one here becomes 2AE1. Okay, this is 2AE1, and then the thermal overload is H5A. Okay, this one here is H5A. So the thermal overload for the main drive is H5A. Okay, this is H5A. So basically this corrects everything. Okay, for the lubrication pump, okay, for the lubrication pump, it's the one which has got the the thermal overload has 4DE3, and then the residue current device has 4DE2. Okay, so this is done. Lubrication pump, then crusher main drive. So the only thing we need to work on Moody is that just the power contactor. You notice that for the lubrication pump, okay, for this lubrication pump, crusher lubrication pump control, the lubrication pump designation is 4DC1. Okay, that power contactor, if this is our power contactor position, this is being targeted by this here coil. Okay, this coil belongs to this power contactor. So this and this are together. Coil for this power contactor. So we need to insert a coil to represent 4DC1. Okay. So what do? I need to come to where it says control, then relay coils or contactor coils, because we just think of this as just a contactor coil. So this here contactor coil as AC here. Okay, I'm going to drag it up in here, and then what we're going to do is we're going to designate this as 4DC1. Okay, this 4DC1. So this one here becomes 4DC1. So item identifier is for 4DC1, and then because we know that, okay, let's see if we can shift these contacts. Okay, these contacts, can they be reallocated to 4DC1? So double click, let's see, 4DC1, yes, we can reassign them, and then of course we can check the operational voltage. Okay, because they were copied, so everything looks okay, we're good. Okay, so this is fine. That's okay. So now, why haven't you changed? Item identifier is 4DC1. Okay, so this is 4DC1. So now this power contactor, okay, this whole set, these two will be like part of the same unit. Okay, this coil belongs to a power contactor which carries these power contacts. Okay, so this is how they're related. Now we have 4DC1. 4DC1 is going to be used in the control circuit, and then of course its contacts are going to be used in the power circuit. Okay, so that's how they're going to be related, which we should have done the same thing with this one here. Okay, for the crusher main drive. So we're going to basically copy this coil, and then this will designate as 2AC1. Okay, this we're going to designate as 2AC1. We designate as 2AC1, and then we're going to shift these contacts. Okay, builder, and then we're going to reassign them to 2AC1, like so. And then of course that's about that. So these are assigned. Okay, so we have both the power contacts and the coil for that power contactor. So these are like together, it's a complete set now. Okay, so this is what we get for our troubles. So we've got the crusher main lubrication pump, and then we've got the crusher main drive motor, so which basically takes care of this piece of information which misled us when we started out. And then so we've got the equivalent of this by way of this circuit. Okay, well, we've got the power contacts, we've got the thermal overload, and then we've got the residue current protection taking care of this part. Okay, and then of course, what else do we need? Okay, so that's just about it. So what do we do now? Now, to show what this whole fuss is about, okay, these coils are rated for, I believe, 120 volts. That's the control voltage, okay. So just to put things into perspective, we're going to come in the Explorer. We're going to come under switches, okay. Switches, we're going to get this power, okay, with this push button here, which is normally open, and then we're just going to use the coils, okay. And I'm going to copy this other start push button, okay. I'm just going to call this as a start push button. Then I'm going to get this other coil like so, and then we do know that essentially what we just need is the live for the control and the neutral for the control. So I'm going to get these input links, okay. I'm going to call this input link, then transformation, rotate right, okay. I'm going to do like so. I'm going to copy this, and then I'm going to link this to the live, or rather the control, okay, which is the live for the control, like so. Data, I'm going to call this as control. I'm just going to call it as control. Now I think we're jumping the gun here, because the control is usually like 110 volts or less, because this is like live to neutral will be what? So let's see. The live to neutral will be like 480 divided by 1.732, which is like 227, and our control, our cores are like 120. So we need a transformer, okay. So we're going to call here, and then look for energy sources. Energy sources, single phase. No, we need a transformer. Do we have, okay, right here, transformer. And then the transformer we need is transformer 3, transformer with 2 windings, okay. Get this one here. Now this one is the one which will get the control, and then this B2 will be linked to the neutral, okay. And then here we're going to say control. I'm going to say control neutral, okay, like so. This one comes here, okay. Let's take this a little bit to the left. So this is our control Z. No, I don't want to do this. I want the whole thing to move, okay. So this transformer here is going to be 277 to 120, okay. Now the reason I'm saying this is going to be 277, because our voltage here, okay, this voltage is 480 volts, which is line to line, okay. So if you've got a line to line voltage of 480 volts, the phase voltage, okay, which is the voltage between the line and the neutral, will be 480 divided by 1.732, which is 277. So 277 becomes the input, okay. Primary voltage 277, and then the secondary voltage is 120 volts, which is our control voltage, okay. So maybe we want to do this, and then display alias, and then display value, okay, like so. So that now on the primary side of things we have 277, and then on the secondary side of things we have 120 volts. Okay, and then of course there's a 0.4 potential earth, so we want to connect this to ground like so. Okay, this is power ground wire. Okay, like that. Maybe let me move it down a bit. So now that we have this, we can move this a little bit down. And seeing as how we are obsessed with using output links and input links, we're going to do that. Control Z. Why am I getting Control Z, Control Z, Control Z? Display value, display. I don't know. I don't need this to show up. Okay, so these I'm going to association output links. Okay, so I'm going to say 120 live. Okay, here I'm going to say 120 live. Okay, and then this one here, okay, I'm going to say 120 neutral. Then I'm going to say 120 neutral. Okay, so 120 live, then U is 120 neutral. Okay, so this is what we have here. Okay, 120 live, 120 neutral, so that when you come to this to the control circuit now, all we're going to need are input links. Okay, so this one is going to be linked to 120 live, so this is going to be 120 live. Then of course this one here will be linked to 120 neutral. Okay, will be linked to 120 neutral, association 120 neutral. Okay, like that. And then the only thing we need to do is do this. Okay, just need to make the connections like so. Okay, so now of course we can file savers, project savers. Just going to call this as plant 008. Okay, So saved. Now we can simulate. So it's something like this. So what we expect is we need to close the circuit breakers. Okay, so circuit breakers closed, and then thereafter what's happening here? So okay, we'll deal with this later, because I was expecting that the live end is the one which would be red. Okay, so when this is done, you can actually simulate, get this here, and then we go for AC, right? So AC, so between terminal block position 1 and terminal block position 2, we've got 480, right? And then between terminal block 16 and terminal block, this one here, okay, TV1, we've got 277, okay? And then on the input side of the control transformer, we've got 277, and then on the output side, we should have 120, okay, 120 volts. So clearly the control voltage is okay, right? So when these circuit breakers are closed, the only thing to control is the power contactors, designation for DC1 and 2AC1, okay? So the only thing we need to do is control for DC1, okay? So we have a clockwise rotation, and then when we stop the motor, it takes a bit of time to stop, so we need to just give it a little bit of torque, okay? Give it a little bit of torque, like so. We can add maybe slightly more, okay? So let's see, right, like that, that's fine. We can do the same thing with this other one, okay? So control to AC1, just control this to AC1 by way, this is the coil. So this coil and these contacts are part of the same power contactor, okay? So when we energize this coil, these contacts are supposed to close, okay? Like that, de-energized, okay? So that's the way that we hope this circuit is going to work. So now twakwata circuit ya lubrication pump, then twakwata na crusher main drive. All this is just to say we have the equivalent of this, okay? We have the equivalent of this power circuit for the crusher main drive. So the only thing we need to create now is for the vibrators and the hydroset, okay? So this is done. So clearly the hydroset is going to have a similar configuration to this, okay, except it will be a forward and reverse arrangement, okay? So we're going to copy this one here, okay? We're going to copy this one, up to there. I'm going to copy that. Okay, maybe let's move it a little bit to the right. Okay, let's delete this, we won't be needing this. And then of course this is going to be the hydroset. Identifier, item identifier, this is going to be hydroset, or if you want, just HDR, hydroset, or if you don't want, you want to remember, it's hydroset, okay? This is the hydroset. So this is going to be the hydroset. It's going to be exactly the same configuration, because the hydroset targeted load to control is the motor, and every motor is going to need thermal overload and is going to need residual current protection, among other types of protection, okay? But if you wanted to have a holistic view, maybe it wouldn't really hurt. Okay, magnetic relay. Okay, so let's get this OL7. So what label do we give this? Okay, so for the crusher main drive, we had H5A, right? So if we need a label for this one, maybe let's just call this as H5A, okay? H5A1, okay? So builder, what is this rated for? Let's see. Magnetic tripping current 15/16. The magnetic tripping current, the actual over the nominal, is 15.6 times. Okay, we'll come and change this later, but the service voltage, I'll have to go for 550, rated for 550. Minimum is design voltage, maximum setting current. We're saying the magnetic tripping current is I/IN. I take it this is the actual over the nominal. Okay, so when the actual over the nominal is this, okay, this we can come and manipulate later, so we're not really concerned with this. Rated design current, anyway, we can just leave everything else as default, but maximum is design voltage is 550, which we have changed. Maximum setting current factor of the magnetic curve, okay, this we'll leave as is, then we'll just leave it as this. Okay, we need to save this. So what I'm saying is we'll add this additional protection function to what we already have. Okay, so the only thing I'm going to maybe just shift this a little bit to the left, then insert this, okay, like so. Then we'll do the same thing for this other one. Okay, we'll do same thing for this other one. We'll make a copy of this, except now we need to insert it in the one for the lubrication pump. Okay, for this one here. Okay, so we just need to move this a little bit to the right, and then maybe, I don't know, should have done this then. Okay, you can think of this as unscripted, so hopefully you're not getting bored. Okay, like so. Then we insert this one we've just created. We're going to insert it in here, like so. And then this is going to be 4DE31. Okay. This is going to be 4DE31. This is going to be 4DE31, right? And likewise, we need to create one in this other circuit. Okay, like so. And then this other one has to do with the hydroset. This right here is the hydroset. Okay, you need to move this like there, hydroset, then crusher main drive there. Okay, then lubrication pump there. Okay, then maybe this should be in capital letters also. This is going to be hydroset. Okay, so hydroset again, we'll make reference to the schematic to say what these labels should be. Okay, so hydroset, hydroset. So the hydroset had overload, thermal overload as 4Ce3, and then the earth leakage as 4Ce2. Okay, so this one here is 4Ce2. Okay, this is 4Ce2, and then this thermal overload is 4Ce3. Okay, it's this one here, thermal overload 4Ce3. Okay, so 4Ce3. So we have this. Again, we'll borrow the symbolic name from the thermal overload, just attached a -1, okay, to give to the magnetic relay. Okay, so this is going to be 4Ce3-1, like that, and then this is what we have. Everything is done. Then we need a coil, okay, for this power contactor for the hydroset. Except for the hydroset, we're going to need two coils. Okay, we're going to need like 2 coils for the hydroset, in the sense that one is 4Ce1, because if you look at the power circuit, okay, we can see that from the control. Okay, if you look at the hydroset, this schematic is for the hydroset. This is the crusher hydroset control. Okay, you see that 2 power contactors are targeted, one for raising 4Ce1, then for lowering 4Ce2. Okay, so clearly one coil will be 4Ce1. So one will be 4Ce1, and then this other one will be 4Ce2. This other one will be 4Ce2. Okay, 4Ce1, 4Ce2. Now, clearly, this control is going to be more like forward and reverse. Okay, so the only thing we need to do is we need to copy these contacts. Okay, I don't want to associate them to anything just yet. Okay, so maybe the port names are free. Okay, let's just pull them up like so. Okay, so I'm going to associate let's do this even for this other one. Okay, so the first set of contacts I'm going to associate to 4Ce1. Okay, I'm going to associate with 4Ce1. Why are you not changing? The group will be transferred to component 4Ce1. The changes will be saved to your program. Okay, hope that it has changed. I don't know why have you changed the other tags. Okay, so this is 4Ce1. Okay, then this other one will be 4Ce2. We need to move these to 4Ce2. I don't know why are you changing the coil? Okay, so this is 4cc2. Okay, so now we've got two power contactors and two sets of power contacts. Okay, that's what we have, because what we're saying is the hydroset operation is basically a forward reverse operation. Okay, so let's see that fixes our problem. Close the breaker, go clockwise. Okay, close the breaker, go anti-clockwise. Okay, so like this. So we're able to go in both the clockwise direction and the reverse direction. Okay, so that's just about it in the case of the power circuit for the hydroset. Okay, so the only other thing we need now are the vibrators. Okay, we need the vibrators. Now, in the case of vibrators, we're saying that each vibrator has got two drive motors. Okay, so if we look at the power circuit and then we look at the vibrators here, you notice that one is O vibrator, then the other one is the west vibrator. So that said, you notice that you've got this circuit breaker, earth leakage, power contactor, then the thermal overload. It's like both of these are controlled by a single power contactor. Okay, and then they are of course sharing a single earth leakage relay. Okay, so I would say the configuration for the vibrator will be pretty much like this one here. Okay, so we're going to copy this. I'm going to copy it down here. Bearing in mind that now we've copied the configuration for the crusher main drive, because we're assuming the configuration for the control of the vibrators will be almost the same. It will be similar. Okay, so having said that, what can we do? Maybe we need this space later on. Okay, like so. Then we can move this up a bit. I don't want to disturb a lot of things. Okay, you can move this up a bit. Okay, what it would mean is we'd maintain one circuit breaker, and then what? One power contactor, and then each drive motor would have this. Okay, so this is one set, and then of course we need another set. Okay, to be something like this. So now this one here will be vibrator 1, motor 1. Okay, so this would be vibrator 1, motor 1. Okay, vibrator, vibrator 1, motor 1, and then this one here will be vibrator 1, motor 2, because we said that as could be seen from the electrical power circuit, that each vibrator has got like 2 drive motors. So our vibrator 1 has got 2 drive motors, and then vibrator 2 has got 2 drive motors. Okay, so this is vibrator 1, motor 1, vibrator 1, motor 2. So that takes care of that. And then these would actually be like this. This one here would come there. It's power phase 2 wire. Okay, then this other one will be power phase 3 wire. Okay, so this basically takes care of, so this configuration, okay, would be more or less what this is. Okay, to be more or less what this power circuit is trying to say. Okay, you've got the 3-phase supply, you've got the isolator, you've got the earth leakage, you've got the power contactor, which is like driving 2 independent paths to one thermal overload, the other thermal overload. Then of course at the terminal end you've got motor 1 and motor 2. Okay, so this is what we have. This is vibrator 1. The configuration is pretty much like this. And then for this particular case, the power contactor, this power contactor will be designated as 4AC1 for vibrator 1. Okay, so 4AC1. So we need to copy this coil like so, and then of course it's going to be called 4AC1. It's going to be called 4AC1. And then if you wanted to be sure of the control voltage, it's 120. Okay, it's 120. And then of course we're going to copy this set of contacts. Rather, we're just going to associate MCR5 to 4AC1. Okay, so we're going to move this set to 4AC1. Again, changes the coil and not the set of contacts, but no worries, we've got that handled. So that's 4AC1. So now this is 4AC1 power contacts, which is associated with the coil 4AC1. So this 4AC1 coil and this 4AC1 set of power contacts are part of the same power contactor. Okay, they are related in that manner. Okay, so do I want to pull these port names a bit out? Okay, like so. So this is what this is. So this is actually vibrator number 1. So now vibrator number 1 and vibrator number 2 have got exactly the same configuration. So I'm just going to copy this here. Okay, I'm just going to copy this right here, and then I'm going to copy it there. Okay, so that's exactly a copy of that. And this particular one now, the only thing we're interested in is realignment. This one is vibrator number 2. Okay, this is vibrator number 2, motor 1. So vibrator number 2, motor 1, and then this is vibrator number 2, motor 2. Vibrator number 2, motor 2. Okay, so when that is done, did we change the overloads, I wonder? Okay, I guess we got carried away there. So the overload designations, okay, the overload designations were so 4AE3, 4AE4. Okay, so I'm going to take this out of the picture. This overload was what? 4AE3. This is 4AE3. 4AE3. And then the other overload is this other overload is 4AE4. Okay, 4AE4, and then there's the little issue of earth leakage. They share a singular earth leakage device. So singular earth leakage device. Singular earth leakage device. So this one comes before. Okay, so you can do that. I'm going to get this. Okay, so the earth leakage device becomes 4AE2. Okay, 4AE2 was the earth leakage, because I assume 4AE3, 4AE4 overloads, then 4AE2 is the earth leakage. So this is 4AE2. This is 4AE2. Okay, so that takes care of the earth leakage device. I would rather we've used separate earth leakage devices, but I'm thinking we just complicate everything and just keep it simple. Okay, so this is what we have to go with. So for this other one, it's essentially the same thing, and I would rather we don't really go through all that editing. So let's just recopy this. and paste it there. And then of course this is vibrator 2, motor 1. Vibrator 2, motor 1. Then this is vibrator 2, motor 2. Vibrator 2, motor 2. And then of course the only other thing we need to worry about are the labels now. Okay, so this one here, we can get the labels or symbolic names from the power circuit. So we're talking about earth leakage as 4BE 4BE2. Okay, so maybe I'm going to do what? This is 4BE2. So we need to copy a coil. They were down here, so let's copy this coil. And paste it right here. Okay. And then we're saying this is supposed to be 4BC1, right? So we're going to associate this set of power contacts to MCR7, okay? MCR7. And then of course this now becomes the 4BC1, okay? It becomes 4BC1. So 4BC1 sorted, right? Port names a bit out. So we've got 4BC1, then we're talking about the thermal overload. Why are you in this position? Okay, so the thermal overloads, this and this. Why am I really that tired? Am I really that tired? You have to realize it's kind of pretty late, so that's my excuse for this appalling performance. Okay. Okay, so I think that takes care of everything. So 4BC1, 4BC1, 4BE2. Maybe let's move this a little bit to the right. As thermal overloads, we're talking about what? 4BE3, 4BE4. Okay, so this is 4BE3. 4BE31. Then this one is 4BE41. This one is 4BE3. Then this one here is 4BE4. Okay. This just about takes care of everything. Okay, so we've got vibrator 1, vibrator 2 in this arrangement. Okay. So what do? We can just simulate one of the two vibrators, because the other one will operate in basically the same way. Okay. So the target coil is 4AC1. Okay. So I'm going to remove this coil here. So let's get this here. Then let's get this one here. Then insert this. Why are you moving with both of you? So then maybe okay. Okay, like this. RR2, R3. This should be RR4. Okay. Y4. B4. Okay, so that's that. So let's simulate this. Close the circuit breaker. Power is starting to flow. And then 4AC1 energize the coil. So both of these are running at the same time. Okay. So let's stop this. Then we said the same thing would hold for vibrator number 2, except we haven't linked the endpoints, the power supply, the 3-phase, to RF5 to this position. Okay, these are not underscored, so they are not linked. Okay, so we come to R1 here. Association is RF5. Yeah, then this one here is Y5. come on, supposed to be Y5, then the last one is B5. Okay, then this one is B5. Okay, so that takes care of that. All we need to do now is simulate this. Okay, so maybe we need to bring our control. We need to bring our control circuit, meaning this one here. The other way, if we don't want to be moving it about, we can do this. Okay, you can get this, and then we just take this instead. Okay, just to avoid us moving the circuit about. So again, close the power circuit breaker, close the circuit breaker, right? And then close this push button. Okay. Then you see that the vibrator motor is actually working. Okay, this is for vibrator number 2. So vibrator 2, motor 1, vibrator 2, motor 2. So this is how the circuit would actually work. Okay, so this basically just pushes us through the power circuits for the vibrators. Okay, we've made some mistakes which we've corrected, but I don't know, I guess sometimes I don't normally use this software, so it takes some time for me to like come back and start using it. So I hope this has been helpful, because what we have done now is shown how to use links, and we've actually configured the power circuits for all the necessary circuits. Okay, so we've got the lubrication pump, and then we've got the crusher main drive, we've got the hydroset, we've got vibrator 1, as can be seen by vibrator 1, motor 1, vibrator 2, motor 2. Okay, and then thereafter we've got vibrator 2, motor 1, vibrator 2, motor 2. So basically these were the required power circuits. So that done, we can get rid of most of the excess circuits. So now you've seen that we've actually created ourselves the necessary coils for the power contactors, which we are going to need in the control circuit. Okay, so we're going to end here, having configured all the required power circuits for this creation. Okay, alrighty, see you in the next section. Cheers.